There's one more problem on Bernoulli. Just see here. Actually, I can do it in different ways. If I use Bernoulli's concept, this problem can be solved easily. But then there's a small twist here. I can write in this format of Bernoulli, that is dy by dx plus p into y is equal to q into y power n format. I cannot write directly. What I should do, just see here. I have a term which is multiplied to the first order derivative, right? So first let me remove that. Dy by dx. This is equal to 1 by xy into 1 plus xy squared. Okay. Then as long as this term is in the denominator, I can't bring it to this format. So simply what I'll do, just reciprocate it. Reciprocate. What that is make it ulta. Make the denominator numerator and make the numerator the denominator. Okay, so I'll be having xy plus x square y cube, right? If I multiply, take it aside, I'll be having something like this. Now, if you see dy by dx by dy minus yx, this is equal to y cube x squared. Or I can say here that it is a linear differential equation in x. Linear differential equation in x. Okay, guys, here I have one small thing. In case you have a doubt of linear differential equation in x, okay. So in case you have a doubt with the linear differential equation in x, make it a point to write linear differential equation in y simultaneously. Okay. And its solutions also you write so that there is no doubt about it. Okay, linear or whatever, Bernoulli. 7.2. Okay. So what's the integrating factor? Integrating factor would be e power integral p dx. And then y into integrating factor. This is equal to integral q into integrating factor dx plus c. Okay, this is in y. Looking at it, write the x part as well. Linear in x also you write simultaneously so that whatever doubts you have or whatever mistakes you tend to make can be resolved easily. Okay. So what would be the integrating factor? Wherever x is there, replace it with y. Okay. Integral p dy is what I will write. Wherever y is there, replace it with x. Q into integrating factor dy plus c. So looking at it, you write it. Of course, now this p of x is no more p of x, it is p of y. Q of x is no more q of x, it is q of y. Okay. So accordingly, what's the non-linearity? Non-linearity is the dependent variable x, the x square term. So I'll be dividing it with x square. X power minus 2 dx by dy minus x power minus 1 into y. This is equal to y cube. Okay. What I will substitute? Let x power minus 1 is equal to z minus x power minus 2 dx by dy. This is equal to dz by dy. Okay. So accordingly, I'll make the substitutions dz by dy. Okay. Of course, with a minus sign, this will be. And then here minus yz, this is equal to y cube. Now, just let me write it to avoid confusion. I'll remove minus first of all. Because higher order derivative should not have anything except plus 1. Okay, yz, this is equal to minus y cube. What is your p of y? P of y is y. Okay, it is linear in z. Linear in z now. Q of y is what? Minus y cube. Okay, so accordingly, I'll write the solution for linear in z. Integrating factor is equal to e power integral y dy. This is equal to e power y square. Okay. Next, what do I have? Solution in linear in z now. This is linear in z. So z into integrating factor. This is equal to integral q of x, q of y it is, y cube. Look here if you have a doubt. Y cube into e power y square dy plus c. Usually we tend to make mistake. Wherever dy has to be written, I'll be writing dx because by default we'll be practicing only linear in y. Okay. Right now I know how to solve this. Make the substitution y squared is equal to t or y cube is equal to t. Anything is fine. Okay. To solve this integral on the right, I'll be making the substitution. What's the value of z that I have taken? Z I have taken it to be y squared. Okay. Integrating factor, I have got it to be what? Integrating factor is e power y square. Right? And then this one, accordingly, I will take. What that is y squared. Y squared is equal to some t I will take. 2y dy would be what? dt. Okay. So y dy would be what? dt by 2 integral minus put it outside. Y squared value is t. Okay. E power y squared value is also e power t. Y dy. Y dy value is what? dt by 2. dt by 2 plus c. Using Leibniz integration rule, I'll be solving it. Okay. T is u. This is v. Minus 1 by 2, I'll take it out. T into e power t derivative is e power t only. Minus t derivative is 1. E power t derivative is e power t only. Plus c. I'll replace back all the values. I've finished replacing back z. Now I'll be replacing t as well. What is t? Y squared into e power y squared minus e power y squared. Of course, I can take e power y squared common, cancel out on both sides and all the things. Y squared is equal to minus 1 by 2. Y square minus 1 plus c e power minus y square. Okay, this is how I will write the solution to Bernoulli differential equation, which is in x. It is not in y. Whenever you have terms multiplied to the derivative, I can't write it in any standard format, be it a Clairaut's Riccati or anything. I cannot write it in standard format. So what I'll do, I'll reciprocate. That's what I have done. Okay. And then made it linear in x and then proceeded to solve. Okay. I'll do one more Bernoulli's in the next video.